Hello, you beautiful students and parents. I hope you're all good and do happy codings. Another episode of Uncle Code Review. Hello, May Sam. Hello, Ash.
Hello.
Hello.
How
Hi,
are you
Uncle
doing?
Hi, Mason.
How's it going on?
Perfect. Very good.
Good. Are you guys ready to go through student
Oh,
code?
I'm
Yes.
excited. I'm really excited today.
So
Big
let us
fat
know,
yes.
who are those two chosen?
Let's see.
Yes. So let us know.
All right. So we have two kids. I don't know if I can actually call them both of them kids anymore. Okay.
Yeah, I'm a kid, so call everybody kid.
Yeah. So first of them is actually Deevak.
Okay.
Deevak. He's been with Kidocode since
Oh,
2017. Yes.
Oh,
He's 18
interesting.
now. You know,
Wow.
imagine that he's 18 now. He joined when he was 14. Very,
I think
very
we have
good
to now
student.
we have to create alumni. Alumni have graduated as students.
Yeah.
Yeah.
It's in progress.
Really amazing. Yeah. And
Interesting.
you know, another thing that is interesting with him is that he actually started slow when it comes to the hours, and then he finished it fast, and then again went for more hours to continue and go for advanced level. Really
Heavy duty.
Yeah.
Human.
Really good.
That's
And-
amazing. Very good. Hello, Deevak. I hope you're happy and healthy wherever you are. And definitely, we're going to see you in one of our programs. We're going to have kind of a little talk about your plans for after the 18. Maybe I can give you some suggestions. And also for other students at your age, I like to do that and tell you guys that how you can utilize what you learn for the next phase. So let's go through the code. I'm just going to share my screen now. I have Deevak code here. Deevak, I want to debug. I want to debug Deevak code. I want to debug Deevak code. So let's go and share the screen. So you guys have my screen, right?
Yeah.
Yeah.
So before I run it, Maysam, anything you want to share with us?
No, it's a very nice and beautiful artwork, actually.
Oh, great.
Yeah.
I see colors, I see random numbers, I see some circles, I see 1,000 times, and I see a speed 10,000. Sorry, Deevak. It's not gonna go more than 100. So let's run it.
Oh, wow. Look at that.
Okay.
Beautiful.
Look at what is happening. Thousands of guys. We have to wait for 1,000 circles. Do you understand? 1,000 colorful circles. So let me just, for the sake of the time, I jump in and make it a little bit faster. So maybe it's also a kind of thing that maybe you could do it. Use a tracer and then give 100. I think it would be good. So run it now. Yes, that's
Yeah.
Oh, wow.
That's very good.
very
This
interesting.
random function is always surprising.
Very interesting. Very interesting.
It's like a
So
painting.
it's like a painting. You can print it. You know what? One of the things that I like to do is print this on my T-shirt. So, and then let me.
You know what reminds me? This test for color blindness.
How many colors you can? How many colors do you see, Maysam?
Yeah, I see 85 inside 92.
You know what? You can do the cheating. Take out how many colors you have in a list.
Yes, if you see, for example, you don't see, if you look at it, you see 8 or 9 or 10, you are you are colorblind, or certain colors you cannot see. You can actually record it like that. It's just random, but you can move it to that one too. Cool.
So let's go to the code. Here, I see total. First of all, speed can be more than 100, so it doesn't make sense how many zero you put there. I know you like to put zeros. I like to put zeros. Everybody like to put zeros in bank accounts. It's not gonna work like that. So, and also here, it's good that when you import something, it's more Pythonic and beautiful to put it on the top of the code. It means first we're gonna put it on the top, and that would be much better. And then we go to your for loops, which iterating around 1,000 times, and you're trying to create the position for each circle. So that makes sense. You're creating a random number from -300 and 300 because the way we set the origin in K Portal, in K Studio is at the center. So from X negative to positive, and do the same thing for the Y. So eventually you have a position to send your turtle randomly. And colors. You know what? You're doing the same thing again and again and again in each iteration 1,000 times. Why are you going to do that? Why not? We put it before the for loops.
Very nice.
Right? And because I just recorded a video today from my Instagram about green coding and how we can write a code in a way that you can, consume lesser CPU or lesser GPU or lesser resources to utilize less of the phone battery, and means people consume less energy and less CO2. So this is one of them, actually. So you don't force CPU to do the same thing again and again, okay? So we just remove it, okay, Deevak? And then we go to here, and then you have a random choice for the D. Let me see, what is the D? Okay, D is the radius you're choosing for your circle. So, okay, good. Again, it's good to use a little bit better name. That means relevant names. So radius, for example, XY is good because it's very mathematical. And then S, and also you have S. So let me see, what is the S? Oh, the D is for the colors. Oh, you got it. Oh, you see, that's how we make mistakes. It's good to have names. See, colors, and then here colors, and then here you can say that maybe circle color, and so then here I will write the circle.
It's supposed to be diameter.
Okay. And this is now diameter. So. And then here we're just going to pick it up from here and then put it, this is there. So now and then here you begin fill because you want to make it colorful, you want to fill it up, and then go to the other position, random position, and then pen down. So we know that pen up and down, let the turtle move around without drawing things. And begin fill and end fill, let whatever you close shapes you create, it will fill inside with the color. And actually, the algorithm that turtle knows a shape is closed is really nice. Convex Hall algorithm is a famous algorithm in computational geometry. It's really, really interesting. In many exams and competitions, they use this one.
It was always a question to me.
Yeah,
how does it recognize it?
Yeah. So then I'm just going to run it. Now let's run the code again. Probably we're going to get the same things. So, because I zoom in, it's everywhere, okay? Because I zoom in the browser. But the result is everything is the same. So beautiful. Look at here, how many elements are engaging together. There definitely is an art. There's an art. There's colors and concepts and orders. And we know that in art, creating random generative art is something that we all aware of it. It's really great. It's really beautiful. And here, how nicely this iterative concept building something in the right side. It means like imagine you don't look at the right side. Just look at the left. So if you show this to people and ask people that don't know coding, which one is more beautiful? Oh, the right one. What is the left one? What is it? It's like old-fashioned text editor or DOS editor. Some people that think coding is DOS, by the way. And then here, if you know coding, you say, wow, that is beautiful. The left one is beautiful. You see what I'm trying to say? When we learn more stuff in our life, we have the capability to see more beauty, the layers of the beauty. Actually, what do we see on surface? For example, many of us look at the flower and we say it's beautiful because it's easy to perceive that beauty. But when we know more, for example, about how is the structures within the flower. You know why some things is red and purple? Because of the electrons and sunlight and reflection. When you know these stuff, you enjoy more. So that's why I urge everybody. It doesn't matter. You want to be programmers, you want to be a chemist or physics. Learn a little bit of everything. That really help you to see beauty in everything, and also teaches you how to think like them. This is the power. We know the knowledge, and I should say thinking is the power. If you can think and you can see the beauty, then that's all good. Deevak, fantastic. I really love what you've done here, especially with colors and mathematics and geometry, all here, all in one place. So easy and so beautiful.
Very nice.
Let's go for the second
like
try.
it. I
Good
like
job,
it.
Deevak. Good job.
Well done. All right, so we're moving to our next kid. Now we're going for more of like girl power. All right.
Great. Let's go. Let's bring some girl power.
All right. So her name is Anabelle. And
Anabelle.
very interesting. Yes, Anabelle. She's now 11.
Oh my!
Yes.
I remember her.
Oh my God, so cute.
her.
I know.
So cute.
I remember her.
Really cute. She joined
Yeah.
back in 2019. And even with just 2 years, she was actually able to create like really interesting electronic projects. I know
Yeah,
Mason, you wanted to
very
say
lively.
something
Yeah.
about this.
It
Yeah.
was very lively and very passionate to do it. Was very engaged and very enjoyable to teaching her new things.
Yeah.
She absorbed it quickly and working on it and debug it and never got tired of things. Something goes wrong, it fix it and try it again. Really fascinating.
Yeah.
Moon spirit. And now how old is now?
Really?
11 years old now?
She's now 11. And, you know, aside from coding, like the Python code that we're going to show later on, she also created a smart house for her Barbie.
Mm.
Oh, that's amazing
Yeah.
for the Barbie house, right? Barbie house.
Yes.
Yeah.
Yeah.
Oh, you are so famous, Annabelle. You're so
Yeah.
famous in Kidocode. You are the queen of Barbie, but in e-Barbie. Electronic Barbie.
Something I really like about it here, the involvement of your joy into your creation. When you love something and we want to create something, let's say I like, for example, blue color, so I start drawing blue. All right. I like, for example, trees. I start drawing trees. I express myself. Okay. So education should be something like this. When you like your toys, you don't have to put it aside to learn something. You can involve them inside your creation. You can bring them inside, and that's, I think, makes education more meaningful, more tangible, more sensational for the kids.
True.
Right? So I'm choosing a correct word for that.
It's good. It's okay. We got the point.
Yeah.
So, I'm going to show the screen now.
Cool. Let's go.
So let me open the file. Okay, now I have it here. Okay, so
Okay, let me add this one. She created out of her own thing. It's not our task in the keyboard. It's
customized.
out of her own imaginations.
Oh,
That's-
nice.
That's great. That's super beautiful. This is exactly constructivism. That is great. So I'm going to run. Do you have anything before I run the code?
Yeah, please, Ron. I see.
Oh, let me zoom out. Okay. We do have I guess it's sunflower, right?
I think it's still. I will be go on. She loved the project. It's
Yeah.
it's an indicator of sunflower indeed.
I think it's a sunflower. Sunflower.
Yeah.
Great. So, first of all, I'm really happy that I know you are the same person. Both the Barbie house and smart house, and now I can see. You see the transition of the skills, coding skills, electronics, combining together, because there's a continuum among them. And that's what I like to see children understand. I think today, modern world continuum is the digital, the IT, the codings, the computational thinking. That's what you're going to see it everywhere, no matter what you're going to do for the future. Sense of that things is important. We call it digital citizen. Now, we must be turn yourself into this concept. And now I can see a child do coding here and does electronic and bring it to smart house and combine it with a brand Barbie, and she can explain. So now you can guess what we are trying to achieve at Kidocode. I'm going to zoom. Okay. So here, what do we have here? We have the thumb, speed 0. Oh, Deevak! She knows how to make it faster.
Very cool.
So then width 5, and then we have 90-degree go to the left, and then forward 300 with the color of the brown. That's what you can see here. Then she draw to the lime green leaves, I guess, with all the LT, FT, backward, right, forward, backward, left. And then she did the rest of the brown lines. So for 200, so we can say that here is 100 and here is 200, right? That's just what you can see here. And then at the bottom, at the very top, there is something little here that doesn't fit into my eyes. Let me see what's going on. I see this circle is a little bit little bit more into the left. Do you see, guys?
Oh,
You see,
yeah.
it's a
You
little
know, I have no comment on all the things.
shopping.
You know, when we were ordering the Kidocode logos, he told me that, oh, I think this is a little bit things, and I couldn't see that, so we brought the rulers and all the things that we measured. Was almost 3 degrees, 4 degrees off. The guy was so shocked that they had to come and redo the logo. So if you say it's not aligned, it's not aligned. Let's go find it out now.
because I can see that it's dropping. It's dropping. Or maybe,
Yeah.
but hang on a sec. Maybe she did this by purpose. Because sunflower, you see, they turn themselves through the sun or the light, Maybe. I don't know, Annabelle. I want to fix it, but if that's was your purpose, I'm sorry for that. Let me know. Okay, I will just get it back. I asked him that you made a mistake here, but that maybe you wanted to make it like that. I don't know. So let's go to the yellow part. Let's see what's going on in the yellow part. That we will see something like that. So here it says pen up and go to, and then okay. So let me comment the code, this part first. Okay, and run it first. I'll zoom out a little bit because so then okay, so we do have now, you see everything is perfect. So we want a perfect circle here. We want a perfect circle. So let's see what's gonna happen if I just bring back the code again and I don't do the go to. Okay, I just do the circle, 50 pixel circle. So
Okay.
what's happening? Let's make it a little bit slower, then we have a better understanding, maybe. Okay. You see from which point the turtle starts to draw the circle, huh? To just in and out the circle. So it means that here, if I'll just let me do this. So it means that from, let me bring up my pen. Which one was
It's a very nice trick. I like it.
Okay. So you see that this is what she's trying to do. Okay, so that's how the circle will be illustrated here. So what I want to do, I want to bring a little bit the circle to the top and the right because I want the circle to be drawn here. So apparently wherever is heading, the turtle heading. So if let's say this is the turtle, let's say this is the turtle head. So from here start to draw the circle. So what if first I turn right 90 degree on Annabelle. So let's do that. And then ask turtle to draw a circle. Because wherever turtle is heading, we draw a circle, then that happened. But what if, okay. So what I'm going to do is I will ask Tom dot turn right. So right 90 degree. First, I'm going to do that. So look at it now, turtle is looking to the right side, right? And then I draw the circle.
Yeah.
Oh.
Okay, so I don't need to do that go to just because in that way, you, Annabelle, you have to guess, trial and error, exactly where is the point that when I draw a circle, it will be fit in the way that the half here and the half the other side. But the point is, if you remember how turtle draw the circle, wherever turtle is there, draw a circle in that point and bring back at that point. So you just turn right 90, then you're gonna have exactly the circle on top of the line, the brown line.
Yeah.
You know what I like it the most? She didn't give up on that one. Okay, the circle is going. Let me find a way. Let me find a way. And I said, okay, if I go there, so it will be in place. But it's definitely this is easier. But I like her solution too. That's going to that locations and things that if she could calculate it. No, I think she was off by a few points. She could get the same result as well.
I think she did guesstimate.
Yeah.
Oh, let me back. Okay. So you know what? There's again, this is again another example of green coding. You know what? Now there is a conversation. It's good to know that Annabelle and Deevak, both of you, you know what? You guys use Google image search engines, and Google uses a lot of artificial intelligence, for example, image processing. That's how Google knows what is the shape of a picture. So when you use your phone or you search for an image and find similar images, there's an argument that most of algorithms we use in artificial intelligence is really interesting. You know what? They say that they don't need to be too much accurate to give a good result to people. If they're going to be a little bit slobby, even a little bit slobby, still they work. So there is a new branch in machine learning and data science that they focus on this part to know that what is that threshold that we don't need to be, too much good. Because if you're going to be too much good, means too much CPU, too much processing, and effectively that reduce the energy consumption. So it's a really interesting way, and
Nice.
we don't need to do really all the kind of deep learnings and this and that for many problems and questions. So it's soon. I think we have to bring some new concepts. I really like to bring it to the Kidocode content to teach children, because when you want to do coding, there are a bunch of ways to do that. There are different ways to do that, but among some of them is more green. Is better. That means we are consumable lesser. So this should be a challenge of mine, I guess. It's a concern of our new generation mind. And I really like to focus on that. We may talk more on these green coding concepts. Fantastic, Anabelle. It's beautiful. Everything you've done is beautiful. Beautiful. It's amazing. We're so happy that you joined the Kidocode and your parent brought you, and thanks to them. And now I'm really happy to see that you, like your sunflower, you are growing.
Yeah.
And growing.
Yeah.
Indeed, very, very supportive parent also. The mom also involved into learning coding as well.
Awesome. Parental account.
Yeah.
Okay.
Very good. Thank you so much, everybody. It was a nice conversation. Gave me energy, gave me hope, gave me love. It was great. Thank you. I love
Let's go for best part.
Thank you so much, Anabelle. I'm gonna see you guys digitally, or hopefully in after all this kind of lockdown in the physical world again. And happy codings, and remember, and do not forget, Deevak and Anabelle, you are programmers.